Mathematics, Analysis and Approaches, Paper 1, Timezone 1, November 2025, question number 6. In this question, he has given us three equations in linear equations in three variables, and he wants us to solve it and get the value for alpha and beta given the condition that this has infinite number of solutions. The concept that we're going to use here is augmented matrix. We're going to make an augmented matrix, and after that we're going to use row operations to convert the augmented matrix to a row-echelon form. A row-echelon form would look like that: 0, 1, some value here, 0, 0, 1, and the values on the right, some values on the right. So that's the goal. I'm going to write the equations in the standard form. Please make sure before you start off doing the augmented matrix and solving using the matrix operations or the row operations, the constant is to the right and the variables are on the left. So the equations can now be written as x plus 0 times of y plus of minus 1 times of z is equal to 4. And then we have a 2x plus 2y plus z is equal to 14, and x plus 2y plus alpha times of z is equal to beta. Let's prepare our augmented matrix. I'm going to write a 1, 2, and then a 2 here. 0, 2, sorry, this is going to be a 1, 0, 2, and a 2, and then a minus 1, 1, and then an alpha, a straight line, 4, 14, and then a beta. The goal, as I said, was to convert these to zeros. So how am I going to do that? I'm going to apply the row operation, which is row 2 will be row 2 minus 2 times of row 1. Along with that, I can also say that row 3 is row 3 minus row 1. So the first row is going to remain as it is. So that's a 1, 0, minus 1, straight line, 4, 2 minus 2 times of row 1, which is going to be a 0. There is also going to be a 0. That's the reason why we applied the row operations. Now this element will be 2 minus 2 times of 0, which is simply a 2. So this is going to remain as 2. The next element will be 1 minus 2 times of minus 1, which is going to be 1 plus 2, which is a 3. And then 14 minus 2 times of 4, which is going to be 14 minus 8. So this is going to be a 6. Now the last row is row 3 minus row 1. So it's a 1 minus 1, which is 0. And then 2 minus 0, which is simply going to be a 2. And then alpha minus of minus 1. So that's going to be alpha plus 1. And the last one is simply going to be a beta minus 4. So that is my operations, and now I aim at converting this to a 0. How am I going to do that? I'm going to say row 3 is row 3 minus row 2. So that's going to give me 1, 0, 0, 0, 2, 0, minus 1, 3, alpha minus 2, because I'm looking at alpha plus 1 minus 3. So that's a alpha minus 2. And then a 4, 6, and beta minus 4 minus 6 is going to be beta minus 10. So let's say I have reached the row-echelon form. Now there's this information in the question which says that the system has infinite number of solutions. So while solving a system of linear equation using the row-echelon or the augmented matrix method, if I end up with something like this: 1 value, 0, 1 value, 0, 0, 1 equal to, let's say, some value, and value over here. This is the ideal scenario. But if I did end up with 0 here and 0 here, then the system has infinitely many solutions. Okay, it may be this, or even I reach with, let's say, 0 here and a 0 here. Even in that instance, I can say that the system has infinitely many solutions. So for this system, I can right away say that alpha minus 2 has to be 0 and beta minus 10 has to be 0. That tells me that alpha is equal to 2 and beta is equal to 10. That is it. That's a 6-marker question. I'm going to quickly discuss the mark scheme for this. Getting the value for alpha and beta, we get a A1 mark, and equating the third row to 0, I get a method 1 mark for equating the third row to be a 0, and getting the correct third row will get me a 1 mark. So that's your 3 mark. And attempting to apply row-echelon form, we'll be getting 2 marks here, A1, and then a method mark, or simply attempting that. So that's your 6 marks. If you're okay with row-echelon form and that's all you want to know, you can stop right this moment. However, I would invite you to continue further to understand how to solve this using planes. So when we talk about an equation of a plane, something like that, let me call this as, let's say, some pi. The equation of a plane can be represented with this and with a normal like that, and this is n vector, which is normal to the plane, and the dr's of the vector, the normal vector, is ai plus bj plus ck. That's the dr's of the normal vector. So we have 3 different planes here, and if it has one solution, if I ended up with 3 planes, pi 1, pi 2 and pi 3, and if it had one solution, would basically mean that all the 3 planes meet at a particular point. You can imagine, right now you should be sitting in a room, imagine the 2 walls and the floor of your room, they all intersect at one corner, and that would be one solution which is satisfying all the 3 planes. That's one solution. What would infinitely many solution be? Infinitely many solution would mean something like this. Imagine the 2 walls of your room, they intersect. When the 2 walls of your room intersect, they intersect at a straight line. Now imagine one more plane passing through that particular straight line, right? So in a sense, you will have like the pages of a book which is passing through one line, and there's so many planes that can pass through one line, and all the points on that line will become a solution for the 3 planes. It may be difficult for you to decipher what I'm saying, so I have Desmos ready for you. So if you notice, I have plotted. So if you notice, this is a plane, and you can see that there is a normal vector which is perpendicular to the plane itself. That's the normal vector perpendicular to the plane. That's the first plane. The second plane, you can see that the 2 planes will intersect at the point, at the line, right? They intersect at the line. And I have the normal vector of that plane. I hope you can see the normal vector of the plane, which is that. Yeah, I can see that, right? So those are the 2 planes. Now, if I'm looking at another plane, which is the resultant plane, you can see that the resultant plane is passing through the line of intersection of the previous 2 planes. Yeah, I hope I'm making sense, and you get what I'm trying to say, right? Okay, so I have already entered the value for alpha and beta over here. You can see that I've mentioned alpha is 2 and beta is equal to 10. If alpha and beta were not 10, and let's say this was some B and this was some A, so your plane would be a bit far away. Yeah. In this case, maybe I can say that they will intersect at a point somewhere here. Maybe. I don't know. Okay, so let's get back. Now that I understand what's happening, let's take the two planes and then try to find the line of intersection of the two planes. Okay, understand that I'm trying to find the line of intersection of the two planes. So can I say that the line of intersection of the two planes is perpendicular to both the normals of the plane, right? If the line is on the plane and the line, if I take this as a plane and then I say there is a line over here and there is a normal, if the vector is normal to the plane, it obviously will be normal to this line also. And therefore the line of intersection of the two planes will be perpendicular to the normals of the planes n1 and n2. I'm going to call this as pi 1. This is pi 2. Let's say n1 vector would be 1, 0, minus 1, and n2 vector will be 2, 2, and a 1. So that's your normals. Now, if I'm wanting to find the equation of a line, what are the things I need? If I'm wanting the equation of a line, I need the point that it's passing through, which is a vector, and lambda times of the parallel vector or the direction vector, right? If I have those two, I can find it. Can I say that the cross product between the two vectors will give me a vector parallel to the vector or the line of intersection? That would happen, right? If I take a cross product, obviously that cross product will end up being a vector which is parallel to the line of intersection. So how do I find the cross product? Determinant I, j, k, 1, 0, minus 1, 2, 2, and then a 1. So it's I times of 0 plus 2 minus j times of 1 plus 2. I hope you know how to find the cross product between two vectors. If you don't, please message me. Let me see if I can make a video on that. Okay, so can I then say that B vector is going to be 2 minus 3 and then a 2. So I got the B vector, which is a parallel vector, and I also know that pi 3, which is x plus 2y plus alpha z is equal to beta, which is pi 3, is a plane passing through the line of intersection. And therefore this plane's normal, which is n3, and that's a 1, 2, and an alpha, this normal and the B vector, they will be perpendicular to each other. Okay, they'll be perpendicular to each other. What does that mean? B vector is perpendicular to n3 vector. Therefore, the dot product of these two vectors will be 0. And what's going to be the dot product? The dot product is 2 minus 3 and 2. And then I have a dot, 1, 2, and an alpha. And that's going to be 0. 2 minus 6 plus 2 alpha is equal to 0. Minus 4 plus 2 alpha is equal to 0. 2 alpha is equal to 4. Alpha is equal to 2. So now the equation is x plus 2y plus 2z as equal to beta. I still need the value for beta. For finding the value for beta, I'm going to take one point which is common to the first and the second plane. What was my first plane? Let's see. My first plane was x minus z as equal to 4, and then 2x plus 2y plus z as equal to 14. So what if I took the value for x is equal to 0 here? Then the value for z will be minus 4. The point here is going to be 0, 9, minus 4. And this point, which is common to pi 1 and pi 2, would also be common for pi 3. All right, simply because the three lines are passing through one point, three planes are passing through one line, and because it has infinitely many solutions, a solution which is common to pi 1 and pi 2 has to be common to pi 3 also. I'll take that and substitute in pi 3. So 0 plus 2 times of 9 minus plus 2 times of minus 4 is equal to beta. So that's 18 minus 8 is equal to beta. It gives me the value for beta as equal to 10. Okay, quickly discussing the mark scheme. Getting the value for beta, which is 10, gets you a 1 mark. And getting a point to substitute gets you a 1 mark. Getting the value for alpha gets you another mark. And using the cross product gets you 1 mark. Where is the cross product? Here. The method mark for using the cross product, and then you get a value of 1 mark for getting the beta, or the b vector, sorry. Interesting question and interesting graph. Yeah, that's it for this video. Goodbye.